Okay everyone, welcome to IB Math Online through Teleschool. We are going to be starting in your book in section 9.7. This is called your linear motion section, and we're going to be doing part of it today. So let's take a look at some linear motion ideas. So with linear motion, the biggest thing that you're going to be looking at is particle displacement. So particle displacement, all that is answering the question of how far did my particle go and in which direction. How far did the particle go and in which direction? So let's take a look at our first example that we have in the textbook, and let's kind of walk through that a little bit and try and explain a little bit about what is going on with particle displacement. So here's our first problem. That is our position function for our particle. So the first thing I'm going to do is I need to figure out where does my particle stop so I'll know which way it's going. So I'm going to go ahead and I'm going to find the first derivative of the s function, which is 2t minus 4. I'm going to set that equal to 0, and when I set that equal to 0, that is going to tell me exactly which way my particle is going to go. And it's going to tell me, more importantly, where it stops. So I'm going to solve this out. And when I do that, I find out that my time where my particle stops is at 2. So I'm going to make a little graph over here, and let's find out what our particle is doing. Okay, so let's see here. I'm going to put -1, 0, 1, 2, 3, 4, 5, 6, 7, and I'm going to end it up here with 8. Okay, so if I'd like to figure out what's going on with my particle, first thing I want to do is I want to find out what is its position at time 0. So when I start my problem, which of the numbers on this chart is it on? So again, take your position function and solve it out, and you'll find out at time 0, your particle is at position 3. So that is your time 0 right over there. Okay, now I found time 2 is where it stopped. I kind of like to know where is it at time 2. So again, I'm going to put this in the position function. And I'm going to solve that out, and it says that it went all the way over to -1. Okay, so that means this is where it is at time equals 2. So my particle traveled this direction. Now I know at this point it has to turn around and start going the other way. And why is that the case? Because it's always the case. So at this point, it's going to start going that way. So when you think about a particle, you want to think about it going in a certain direction, and then when it hits a stopping point, it's going to reverse directions. So what I can tell from this is I know how far my particle went. It went 4 units, 4 meters. Okay. It went to the left 4 meters. Okay, so I can answer the question of how far did it go and which direction. Now, if I would like to know what the particle is doing between a certain time period, so let's say that I wanted to know what it was doing between 0 and a certain spot, I can figure that out as well. So the example that's in the book said, I would like to know what it's doing between time 0 all the way over to time 5 seconds. Okay. Now, I don't know exactly where it is on here because this is a rough sketch. So I'm going to put in here and find out what is the position at time 5. So if I put that in, I'll have 5 squared minus 4 times 5 plus 3. So it looks like it's going to be at 8. So at time 5, it's all the way over here at 8. So that's t equals 5. So here's what I know about my graph is I can figure out what the displacement is from where it started to where it stopped. So from where it started at time 0 all the way over to 5 seconds, it actually went from 8 minus 3, so 5 meters. Now notice that's not taking into account the fact that it went backwards. It's just taking into account that forward motion. So the way that the book describes this is if you take T1 and T2 and you find your velocity function, you integrate it, in other words, giving you back to the position function, that's the same thing as doing S of 5 minus S of 0 if we want to go from time 0 to time 5. And we know, because we did a little calculation on that, that if we're starting at 8 and we're subtracting off that 3 from where we started, those numbers are coming from here and here, I will get 5 meters of overall movement. Now, what if I'd like to know the distance traveled? So if I want to know the total distance, that's pretty simple as well, because I know I went 4 meters to the left, plus I went 8 meters to the right. So that's a total of 12 meters of total distance moved. Now, when you're thinking about total distance, you want to think about it just like you were in a car. If you were in a car and you went backwards and forwards, that odometer in your car is going to count that. Doesn't matter whether you're going backwards or forwards. So even though I went to the left here and to the right here, total distance is this. This is our displacement. So make sure when you're reading the question that you're paying attention to whether you want total distance or you want the displacement, because it's going to be a little different how you calculate those two. Okay, so let's take a look at that first example. That's example 17 in your textbook. So example 17 says it would like the displacement for the particle. So here's your function that will give you the displacement. Notice that time as always says that it's greater than or equal to 0, and that's because we cannot travel backwards into time. Okay, so first thing, ask for your velocity function. That's the first derivative of your position function. So let's find that first. Okay, so the 8 goes away because it's a constant. That will be a 2 plus 2t, and that is going to be your first derivative. So just to remind you, that is s prime of t. We're going to be going back and forwards, integrating, and everything like that. Now the next thing is it says, when is it moving left and right? So if you want to find out when it's moving left and right, in other words, make one of those tables we just talked about, you need to find out when this function stops. So I'm going to find out when the function stops moving. Oops, looks like I miscopied it. Let's make that a negative, make that a negative, make that a negative. So my t comes out to be 1. All right, so at time 1 is where it's going to stop. So we're going to kind of do B and C together. B and C wants you to make a particle diagram and see what it's doing. All right, so let's take a look at our different movement. So I'm going to start here with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice I left some space if I need to go negative to the left. Okay, so first thing I want to do is, where is my function at time 0? So I'm going to do s of 0. I'm going to put that into my original function because I want to know where is my graph when I start. Okay, so that's 8. So that means that I'll be starting way over here at 8. So that is where my function is at time 0. All right, next thing I'd like to know is I know that my graph is either going to go to the left or the right. I don't know which one yet. So I'm going to find out what it's doing at the time right here, the one that I calculated for where it stops. That will tell me if it went to the left or it went to the right. So I'm going to do 8 plus 2 times 1 minus 1 squared, and that's going to give me 9. So that means that my particle went to the right, which means afterward it's going to turn around and it's going to go back the other way. Okay, so that's what my graph is going to look like on this one. So the problem for part B asks, find when the particle is moving to the right and when it's moving to the left. So like I said, I'm doing B and C together. So I know that my particle is going to the right, starting at 0 for my time, going to 1, and then I know it's going to the left, anything past that. So that's what it's doing. Okay, the last thing is, it says write the definite integral for the displacement. Okay, so going to D, I know and we'd like to know between time 0 and 4. That's specified in the problem. So I know that what they're going to say is do the velocity function, which is 2 minus 2t dt. And they would like to know the answer on that. Okay, so we're going to work that problem out, and then I'm also going to show you up here on the diagram. All right, so let's see here. I have 2t minus 2t squared over 2, and this is going from 0 to 4. So let's see here, that's going to be 2t minus t squared, going from 4 to 0, 0 to 4. All right, so if I calculate this over here, that'll be 2 times 4 minus 4 squared. All right, negative 8. Okay, so what does that mean exactly? If I look up here and I'm going from time 0 to time 4, and by the way, I'd like to know the position at time 4, so I'm just going to add that over here to my positions. It turns out when I'm over here at time 4 that my position is at 0. So that is t equals 4. That means from where I started to where I stopped, that distance is 8 meters. Now, what if I would like, so that's my displacement, right here, displacement. On the other hand, I might want to know what the total distance traveled is. So if I want total distance traveled, I'm going to need to do a little bit more work. My total distance it's going to be a little different. That's going to be the one that I traveled going from 8 to 9, plus I'm going to need to add on the 9 spaces going the other way. So my total distance traveled in this case is going to be 10 meters. So make sure that you're paying attention to your graph and the question that's asked. All right, now our last example that we're going to be looking at today before you get into your problems is we're going to be looking at a function. That has to do with particle movement. Now they have given you a graph. This is a copy of the graph that's in the textbook. And they would like to know a couple of different things about it. So the first thing that they would like us to figure out is they would like us to start by finding our displacement. So remember, we're going to be looking at an integral, which is area under the curve. Now, this one's a little weird because as you can see, you have a triangle, and a trapezoid. So we're going to use what we know about these problems to help us figure out our problems. So let's start off with area A1. So that is this triangle that's down here. That's A1. So when I try and do that calculation, it's going to be 1/2. Then I need to know how wide my triangle is. And if you're actually looking at the picture that's in the textbook, it crosses right there, which means that my base would be 4. And my height is the same thing, also 4. So A1 is going to have an area, and it is going to be, looks like 16 to -8. All right. So now let's go to their second triangle, the one that's right there. That's A2. So if I look at A2, A2 is again 1/2. And my base on this one starts at 4 and it goes all the way over here to 12, so that's 8. And my height on this one is 4. So doing a little mental math, that's going to make that 16. Okay, and now let's come over here and look at the trapezoid. Just to remind you, trapezoid is area equals 1/2 base 1 plus base 2 times your height. All right, so if I'm looking at those two bases and doing that problem out the correct way, it's going to be 1/2 4 plus 1, those are your two bases, and your height in this case is 2 units. So looks like that's going to be minus, so it's 5 to 10 divided by 2, that's 5. So when I do my calculation here, it's going to give me a displacement of 3 meters. Okay, so that is this area minus this one minus this one. All right. Now, the second question on that is, what's your total distance? So total distance is going to be a little different. So in this case, we want only positive values. Now, we have already calculated A1, and again, I want to look at that positive area. So notice I'm not going to make it negative this time. Then I'm going to get my second area. That's that big triangle right there in the middle. And then I'm going to get the trapezoid at the end. Okay, so let's see here. So that's 8, 16, 5. So that is 29 meters. That would be the total distance that my function has traveled from beginning to end. All right, so at this point, homework time. So your homework can be found on page 324. It's 9-0, not 0, numbers 1 through 3. Okay, so 1, 2, and 3. Let me pull the book over so we can take a quick look at it. So those are your problems over here. In each case, it's telling you that you need to, scoot up just a little bit, that you need to find the velocity of the particle, draw a motion diagram of the particle, and write a definite integral to represent the displacement and total distance traveled. So this one's got a nice diagram. These two are more, these three that are up here, they're just functions. Again, if you want to look at them in your calculator, you're certainly welcome to and graph them. Notice that they have the calculator symbol over here on the side. So hopefully this day goes well. Remember, ask me questions if you get stuck.